Today in the workshop, we'll be working with infrared remotes. We'll learn how these devices work and how we can decode them with our Arduino. We'll also learn how we can use an Arduino to make our own custom infrared remotes and how to use these devices in our projects. So don't change channels, and welcome to the workshop. Hey, welcome to the workshop. Today we're going to be working with infrared remote controls, those devices that I'm sure you have all over your home. Now, infrared remotes are very useful, as evident because they come with just about every piece of audio and video equipment that you'll ever purchase. But there is a lot that we can do with an infrared remote, especially when we couple it with an Arduino. So we're going to cover quite a few things today. First, we're going to start by explaining how infrared remotes actually work, because I think it's always important to know how something works before we start playing with it. Next, we're going to see what we can do with some of these remote controls that we have around the home. We're going to use an Arduino to decode the output of these, and we'll see if we can repurpose them. For example, I've got a remote here for a television that has features for a DVD or Blu-ray player that I never use. I could repurpose some of these buttons to, let's say, turn off lights or fans or something in the same room as the television and make the device more useful. We're going to look at doing things the other way too, taking an Arduino and emulating an infrared remote so that we can make our own custom remotes, maybe one remote control for all the devices in our room, or perhaps a simpler remote, one that only has the buttons that we really use rather than 20 or 30 buttons that we never use and is kind of confusing. And then we're going to look at using one of these inexpensive infrared remotes that you can pick up on eBay. These things are really cheap and they can be used for all kinds of projects. So we're going to put together an Arduino project that uses this. So there is a lot to cover today, and so let's get started and learn how IR remotes actually work. IR remote controls use light to transmit data between the remote control and the receiving source. The light they use is infrared light. Infrared light is light below the visible spectrum of light. An advantage of IR remote controls is that IR LEDs are inexpensive. A disadvantage is that IR is subject to interference. Common sources of interference to IR remote controls include sunlight. Another common source is the lighting in your home, although today's modern LED lights emit far less IR than old-fashioned incandescent lights did. Now, IR remote controls work by sending pulses of infrared light to the receiving source. To prevent interference, these pulses are modulated, usually at a frequency of 38 kHz. Each button on your IR remote control sends a unique code to the receiving source. These codes differ between manufacturers. Now, one unfortunate fact of life is that when you're building a project, sometimes it doesn't work the way you want it to. Murphy's Law just sometimes works against you, and you have to start troubleshooting. Now, when you're troubleshooting a project that's based upon an infrared remote, you've got an additional problem. You can't actually see the light with your eye. But fortunately, there is a way that you can see infrared light, and that's to use a camera that does not have an infrared filter. You probably have one, and you may not even realize it. The camera in your phone or in your tablet is usually capable of seeing infrared light. So I want to show you that right now. I've got a tablet over here. I've got the camera on, and I've got one of my infrared remotes. And so I'm going to get up close and personal for a second here and flash and aim the remote at the tablet. And as you can see, you see a flashing violet light. That's actually the infrared LED being pulsed as I'm pressing the button. So you can use that technique if you need to determine that your infrared remote is indeed transmitting. And if things aren't working, you can start looking at the receiving side instead. Alright, so now that we've seen how IR remotes function, let's take a look at how one of the sensors actually works. Now I'm going to be using a very common 3-pin sensor. It's based around a device called an 1838 IR sensor. And the module I'm using is hooked up very simply. It's got a VCC, a ground, and a signal connection. So the VCC is connected to 5 volts, the ground is connected to ground, of course, and the signal output is what we connect into our Arduino or other microcontroller. So I've got one of these devices here on the breadboard, and I'm just powering it up with my 5-volt power supply. I just want to show you how this works. Now, I've got a logic probe. We used a logic probe in a previous video, and this basically is just a device that can sense whether a signal is at a digital 0 or a digital 1, and it does so by both flashing a light and producing a rather irritating sound. And so when I connect the output of my sensor to my logic probe, we see that it is at a digital high right now, indicated by the red light and the high-pitched sound. So I'm going to fire a remote control at this. And as you can see, it creates a number of pulses every time. So this device is actually demodulating the modulated signal and producing pulses, which will then decode and determine which key on the remote that I've pressed. So now that we've done this, let's take a look at our first Arduino circuit that we're going to use with this device. Now the first demonstration we're going to do with an Arduino is very simple. Here's how I've connected the sensor up to the Arduino. I've taken the 5 volts from the Arduino and connected it to the VCC on the sensor. I've connected the ground on the Arduino to the ground pin on the sensor. I've taken the sensor's output and connected it to digital pin 4 on the Arduino. Now the digital pin is not critical. You could use another one if you wish, and you'll just have to change the sketch accordingly. So now that I've done that, let's take a look at the sketch we're going to be running. The sketch makes use of an IR Remote library, which is written by a fellow named Ken Sheriff, and you can find that in your library manager. So go into your library manager, go Include Library, Manage Libraries, and look for IR Remote. Now there's this robot IR Remote which comes installed with the Arduino. This is not the one we're looking for. Continue to scroll down until you see IR Remote by Sheriff. If yours isn't installed, click the button after you click More Info and install the latest version of the library. Now that you have the library installed, let's go through the sketch. First of all, of course, we include the library. Next, we'll define the pin that we've connected the sensor to. I've called it receive pin, and I've defined a constant for it, and it's set to number 4 because I've used pin 4. Again, if you use a different pin, just change the 4 accordingly. Then we need to set up an object for both the results and the receiver itself. So first of all, we set up an object called IR receive, and we set it to the receive pin that we've defined earlier. And then we set something simply called results, and this will store the results of our IR receiving. Then we go into our setup routine. Now we're going to use the serial monitor to display the codes that come from the IR remote. So we'll start off our serial monitor at 9600 baud. You can use a different speed if you wish. And then we'll simply enable the receiver by taking our receiver object and using the enable IR in command in order to enable that. Then we go into the loop, and the loop is very simple. If we actually decode and get results in the result object, then we'll just simply print the result. And we're going to print it in hexadecimal because this is the customary way of printing the results. And then after that, we will resume listening again, and this continues on and on in the loop. So now we'll upload that to our Arduino. And then we'll open our serial monitor to take a look at the results. So I'm going to use a remote control right now and just aim it at the sensor and see what kind of results we get. And as you see, we get a number of numbers whenever I press buttons. You'll probably notice a number of them say FFFF, FF. And actually what that is that's the repeat signal that most remote controls give. So when you hold the key down for a period of time, it simply sends that out to indicate that you're repeating the key that you held before. And we'll take a look at how to use that a little bit later on. Now, as I mentioned earlier, different manufacturers use different sets of code to their remote controls, and some manufacturers share the same sets of codes between different remotes. And so it's very helpful sometimes to figure out what set of control codes your remote is using. This can explain sometimes why two remote controls will interfere with each other when they're used in the same room. So the next sketch we're going to look at will display the manufacturer of the codes that your remote is using. So let's take a look at it right now. This uses the exact same hookup as our previous sketch, so there's no change to the Arduino hookup at all. Now, in this particular sketch, we start off exactly the same as the last one. We'll include the IR Remote library. Again, we've got our sensor hooked up to pin number 4. We'll define objects for both the receiver and the results. And we go into setup and we do the same thing. We're going to use our serial monitor and we're going to enable our IR receiver. And then we go into our loop. Once again, if we decode some results, we will print the value out in hex. But then after that, we're going to also use the decode type property of the results object. And we go into a number of different case statements. So if it's NEC, we print out NEC. If it's a Sony, we print out Sony, RC5, RC5, etc., etc., etc. And that's basically the entire loop. Once again, we resume after doing that, and then we go back through the loop again and continue on and on and on. So let's upload that to our Arduino and take a look at it. So now that it's uploaded, let's open up our serial monitor and try this out with a few remotes. Okay, I'm going to start off with this RCA remote that I've used before. This is for a television that I have. And let's just aim that at it. And as you can see, it's using an NEC command set. Now let's take a look at this little remote control that we're going to use a little bit later. This is the one that comes with that little kit that you can get on eBay or Amazon. And we find out it's also using an NEC control set. I've actually found the NEC set is the most popular among the remotes I have. Now here's a Sony remote control, and as one might expect, it's using a Sony command set. And I've got a Panasonic over here, so lo and behold, it's using a Panasonic set. I also get a few unknowns on this particular one, and that's because this is a multi-remote and it has some codes that just doesn't seem to be in the common library. So you'll find that as well. You'll also find that some remotes, for example, my Sony over here, I think sometimes gives me some Sanyo remote control codes on it. So it's interesting how these get mixed up on the same remote. But at any rate, that'll display the manufacturer type. So let's go on and do something a little practical with our remote control. You saw earlier that I had this RCA remote control, and it's for a television I have. Now, the thing about this remote is that I only own the television, yet the remote has a number of extra buttons on it that are for a DVD or a Blu-ray player that I don't actually own. And these buttons are totally useless to me. So what we're going to do in our next sketch is we're going to repurpose these buttons so that I can do something else with them. So the two buttons I've decided to repurpose on my remote control are this red button at the bottom here and the yellow button, because again, they're for functions that my television doesn't actually use. And so in order to do so, I've added a few extra components to my Arduino circuit, specifically a red LED and a yellow LED, along with a couple of dropping resistors. Now here's how I've hooked this up. I've taken pin 8 of the Arduino and hooked it up to a 330 ohm dropping resistor, and then hooked the other end of that resistor to the anode of the red LED. Then I've taken pin 7, hooked it up to a 330 ohm resistor, and taken the other end of that 330 ohm resistor and hooked it up to the anode of the yellow LED. Then I've tied the two cathodes together and hooked them up to the ground line on the Arduino. So now that we've seen how this is wired up, let's take a look at the sketch I'm going to be using in order to accomplish this. Now the sketch starts off in a similar fashion as the previous one. We include the IR Remote library by Ken Sheriff, and we define the receive pin as number 4. But now I'm defining a couple of other constants as well, specifically red pin, which is number 8, and that's for the red LED, and yellow pin, which is pin 7 for the yellow LED. Now again, if you wish to use different pins, just change the 8 and the 7 accordingly. I've also defined another integer called toggle state because I want one of my LEDs to be a push on, push off. And so the toggle state is going to remember the last state, and I'm going to initialize it with a value of 0, which means the LED is off. Then I'm going to define the IR receiver and results object exactly as we have in the previous sketches. Then we go into the setup. I'm going to enable my IR receiver. And I'm not using a serial monitor this time, so there are no commands for the serial monitor. And then I set the LEDs as outputs using the Arduino pin mode command. So I set both the red pin and yellow pin as being outputs. Now let's go into the loop. Once again, we take a look and see if we've actually decoded some results from our IR remote control. And we're going to use a switch in case function over here. So what I've done is I've captured what the value of both the red and the yellow keypad are using the first sketch that we tried. So I've got this value for my red keypad and this value for my yellow key button. Now, of course, if you're doing this, you're going to have to change these values to match the ones on the remote control that you're using. So on the red LED, I'm going to have it turn on for 2 seconds and then turn off every time the button is pressed. So what I do is I do a digital write to the red pin and I send it high, delay for 2 seconds, and then I send it low again. And then I need a break statement because that ends this case statement over here. Now, in this case over here where the yellow button is pressed, I want to toggle this either on or off. So in this case, I'm going to do things a bit differently. I've got an if statement over here, so I examine the toggle state. If the toggle state is 0, that means the LED was off, so I want to turn it on. So I'm going to turn the LED on, and then I'm going to change my toggle state to be a 1. If that's not the case, I'm going to do the opposite thing. I'm going to turn the LED off and change my toggle state to be a 0. And again, a break ends this particular case statement. Then once again, we resume listening and just go through the loop. So let's take a look at how that actually works. So over here, I've got my remote control, as you can see, with the red and the yellow buttons, and I've got my LED. So if I hit the red, you see the LED comes on, and then 2 seconds later it goes off. So I can just continue to toggle that briefly on and then it comes off. Whereas the yellow one is a toggle, so if I press this, the LED goes on and it stays on. And it'll stay on until I press the yellow button again and I turn it off. And as you can see, that functions quite well. Now our last demonstration illustrated how I repurposed 2 of the buttons, the red and the yellow one at the bottom of my remote control, and made them control a couple of LEDs. And that's great for a demonstration, but obviously for something practical you would probably want to control other devices, such as a lamp or a fan in your room. That would actually be a proper use for something like this. Now if you're going to be doing that, that means you're going to have to be controlling line voltage. And in order to control line voltage, the best way of doing that is with a relay. I've got a couple of relay modules over here that I like using. This one has 2 relays on it, and this one has 8 relays on it. What I like about these modules is that they're already pre-wired, so you don't have to actually do any wiring directly to the relays. And they've got opto isolators on them so that they isolate the high voltages on the relay from the Arduino. So even if something were to go wrong with the relay, you still wouldn't pass any high voltages to the Arduino. Now if you're using these modules, you should power them with their own 5-volt power supply, not the one in the Arduino. For one, the Arduino probably doesn't have enough current in order to drive a couple of relays, but secondly, that's an additional form of safety by isolating the power supplies between the two devices. And on the subject of safety, if you are going to be experimenting with high voltage devices, be very, very careful. Never experiment with high voltage on the workbench. Always use things like LEDs like we used earlier, and then when you wire your circuit, verify it with a multimeter and that. But don't actually use the high voltages on the workbench. Make sure that you wire it into an insulated enclosure. Make sure the wiring for the high voltage is 18 gauge or 16 gauge. Don't use anything thinner than that. And be very, very careful. Remember that depending where in the world you are, the voltage you're dealing with could be anywhere from 110 to 240 volts, and that can be lethal. If you are not sure of what you are doing, if you've never worked with that kind of voltage, just don't do it. Find someone else who is qualified and capable of doing it to assist you, or just simply do not do it. Do not risk anything because, again, these voltages can be lethal. So with the safety message over, let's move on to our next experiment. So far we have seen how we can use the IR Remote library to receive and decode remote control codes, to determine the manufacturer type of the remote control codes, and to even repurpose a remote control to perform other functions. But the IR Remote library can also be used to transmit remote control codes, and that's what we're going to do right now. I've taken this little RCA television and put it on my workbench. Now it's the TV that's associated with this remote control that we played with earlier. And basically what I've done is I've emulated the power button with the next demo we're going to do. So the power button toggles the television on and off. Now you could emulate any other button that you wanted to. I just chose the power button for this demo. You could even emulate a series of buttons, and they don't have to be to the same device. So there's a real practical use for this. Let's say you have a television and a sound system and a Blu-ray player, and you need to turn on the TV, set it to HDMI input number 2, turn on the sound system, set its input up, turn on the Blu-ray player. That's a whole bunch of buttons you'd have to press. Well, you could make one button that does all of them and just fires off the remote control code. So it can be very convenient. Now, in order to do that, you'll have to do what I did in order to emulate the remote control here, and you'll need to determine the code and the manufacturer type, which we saw with the second demo that we did. Another thing you need to know, though, is the different manufacturer types transmit a different number of bits with each stream, and you need to know that. Now, that's a little bit difficult to find that information. I've got some resources on the dronebotworkshop.com website in the article that's associated with this video that can help you determine the number of bits for your remote control. But they vary between different manufacturers. Essentially, the NEC remote control codes that are used in this RCA and that are used in this little cheap one that we got from eBay, they use 32 bits. The RC5, which is another very common remote control set, uses 12 bits. Now, the Sony remote that I used earlier can use either 12 or 20 bits, depending on the type of Sony remote, so it gets even confusing between manufacturers. RC6 is another type that uses 20 bits, and the Sony and RC6 protocols require that you send the code 3 times, so you have to go through a loop and repeat it 3 times. You may have noticed when I demoed with the Sony remote that every time I pressed a button I actually got 3 codes. That's because the protocol requires that. Again, you'll find a resource on the dronebotworkshop.com website to help you determine the number of bits. Now, in order to do this, I've wired up a little Arduino circuit, and it's wired as follows. I've got an Arduino Uno, an infrared LED, which is like a regular LED, except of course it transmits in the infrared light zone, a push button, a 10K resistor, and a 150 ohm resistor. And I've wired it as follows. I've taken pin 3 of the Arduino and connected it to one end of the 150 ohm resistor. And I've taken the other end of the 150 ohm resistor and connected it to the anode of the LED. And then I've connected the cathode of the LED to the ground of the Arduino. Now, you need to use pin 3. This is one of these instances when you can't change the pin number, and that's because the IR remote uses pin 3 because it's associated with one of the timers inside the Arduino, so this can't be changed. Next, I've taken the 5 volts from the Arduino and tied it to one end of the push button. I've taken the ground from the Arduino and hooked it to one end of the 10K resistor. I've taken the other end of the 10K resistor and hooked it to the other side of the push button, and then I've taken a line from that connection and hooked it up to pin 7 of the Arduino. Now you could use a different pin other than pin 7, and you could just change the sketch accordingly. So now that we've seen how all of this is wired up, let's take a look at the sketch we'll be using in order to emulate our remote control. So here's the sketch for our transmitter. We start off by including the IR Remote library, just as we have for our previous sketches, and then we define a pin that we'll be using for our switch. So I call switch pin equal to 7 because we've got our switch connected to pin 7. Of course, if you used a different pin, you'd just change the number 7. Now notice we are not defining a pin for the output because the output has been fixed on pin 3, and that's part of the IR Remote library. The next thing we define is an integer that I call button state, and I set it to a value of 0. This represents the value of the push button, 0 being not being pushed down and 1 being pushed down. Then I create an object called IR send. So I create an IR send object. And then we go into our setup, and the setup is quite simple. I just set the pin mode of our switch pin to be an input. This is the input from our push button. Then after that we go into the loop. First of all, we read the value from the push button, so we do a digital read on the switch pin and assign that value to the button state. Now if the button state is high, this means that the button has been pushed. And so we use our IR send object, and we use the send NEC function in order to send the code to the television. Now the send NEC function works as follows, and there'll be a send Sony function, a send RC6 function, etc., etc. First of all, we're using a hexadecimal number, so 0x just means that the following code is hexadecimal. Now this is the code that I captured for my power button, so FEA 857. Of course, when you do this experiment with a different television and different remote, you'll need to change this value. Then, as you recall, the NEC codes require 32 bits, so that's what the second parameter is 32 bits. And this is the power code for my television. And then after that, I just add a small delay. This is to debounce the push button so that when I push it, I don't get a series of on, off, but it lets the button have a time to settle down. So that's basically all that the code is. So now let's take a look at it and see how it functions. Okay, so let's demonstrate the little circuit that we've wired up to emulate our remote control on-off switch. I'm going to go over and press my push button. And lo and behold, my television turns itself on. Now, I don't have any input connected to it, so that's all we're going to see. So since it's not that interesting, let's press the button again, and the TV turns off. So as you can see, this works very well. One thing to note is that the infrared LED, I bent it so that it was aiming at the television. Remember that the light from the LED, like in any LED, comes out the top and not the sides. So if you're having trouble with your circuit, you might want to look at that. Also, when you're troubleshooting, of course, you can use your telephone or your tablet to make sure the infrared LED is transmitting. You should see it flash when you push the button. Another thing you could do if you don't want to use your phone is just temporarily substitute a red LED in its place, and you should see it briefly flash when the button is pressed. Now for our final demonstration, I want to show you how you code for the repeat function in the remote controls. You might recall from the first demo that whenever I held a key down, I got a series of Fs, and that just indicates repeat the last key that was pressed. So in order to demo this, I've got a little demonstration hooked up with a remote control and a servo motor. Now the remote that I'm going to use is this little one that I got off of eBay. It's very inexpensive, and it comes complete with not only the remote control, but also with an IR receiver module and with an infrared LED. So it's a very, very inexpensive and useful way of getting into remotes and adding them to your project. I'm going to look at doing 3 of the keys on this remote. The left one, the OK one, and the right key. And what I'm going to do is I'm going to hook it up so that it drives a servo motor. When I hit the left key, the servo motor will move a couple of degrees to the left. When I hit the right, it'll move a couple of degrees to the right. When I hit the OK key in the center, the servo motor will center itself. And if I hold down the left or right keys, the servo motor will continuously rotate in that direction until it comes to the end of its travel. So let's take a look at how I'm going to hook this up, and then at the sketch that we're going to use in order to accomplish this. Now for this demonstration, we're going to require an Arduino Uno, an IR sensor module, a small servo motor like an SG90, and a separate 5-volt power supply for the servo motor. We're going to hook it up as follows. The IR sensor will be hooked up identically to the way we did in the previous experiments, with VCC connected to the Arduino's 5-volt out, ground connected to the Arduino ground, and the output of the sensor connected to pin 4 of the Arduino. Next, we will hook our servo motor up. We'll connect the positive to the servo motor's 5-volt power supply positive. We'll connect the negative to the 5-volt power supply ground, and we will also connect that ground to the Arduino's ground, so we have a common ground. Finally, the drive pin of the servo motor will be connected to pin 6 of the Arduino. And so now that we've seen this, let's take a look at the sketch we'll be using in order to make it work. Now in our sketch, we'll start off by including the IR Remote library, as we have for all of our experiments. We're also going to need to include the Arduino Servo library, which is already included in your Arduino IDE. Again, we'll define a receive pin for the sensor, and I've defined that as being pin 4. We also need to define a pin for the servo, which I've connected to pin 6. Now I've defined an integer that I've called pause, and this represents the position of the servo motor. I'm initializing it with a value of 90, which will put the servo motor in the center position when the sketch starts. I've also defined another variable, a long, called last code, and this stores the last code that we received from the remote control, and it's used in the repeat function. Once again, we'll define an IR receiver and some results objects. We also need to create a servo object. And now we move into the setup. We start by enabling the receiver. We attach the servo motor to the servo pin that we defined earlier, and we'll write to the servo motor, giving it a value of 90 so the servo starts in the center position. Then we go into the loop. When we actually receive something from the IR receiver, we'll go as follows. The first if statement checks to see if we're receiving nothing but a value of F's. This means that it's a repeat. And so what we do is we assign results.value to equal the last code that we received. Now if results.value equals FF22DD, then that indicates the left button has been pressed. If you're using a different remote, you will need to change this value accordingly. When the left button has been pressed, we assign last code to the results value. We move the servo ahead by 2 degrees by adding 2 to the value of pause. Now we make sure that pause is not exceeded 180, because that's the limit of the servo's travel. So if it goes over 180, we just make the value into 180, and then we write that out to the servo motor. For the right button, we do virtually the same thing. We detect the right button code, which in my case is FFC23D, and we do exactly the same thing, except we minus 2 from the value of pause to move it right 2 degrees. And finally, if the center button has been pressed, we set the value of pause to 90, and we write that out to the servo motor. Now at the end, I've placed a slight delay, and that's to present false readings from when the button is being pressed down. And then after that, we just resume everything and go back and start the loop over and over. So now that we've seen the code, we'll upload it to our Arduino and watch it work. Okay, let's watch our project in action. I placed a little piece of blue paper behind the servo so you can see its position a bit better. And I've initialized it so it started off in the center position. So I'm going to hit the left key. I'm just going to press it once. And as you can see, every time I press it, the servo moves a bit. Now I'm going to hold it down.
and as you can see, it continuously moves. I'm going to do the same with the right key. Hold it down. It continuously moves. If I press it once, it just moves a bit. If I hit the center button, it goes back to the center. So I can move my servo back and forth, and when I hold down the key, the repeat function is working.
Alright, so that wraps it up for our look at IR remote controls and how we can use them with the Arduino. Hopefully it's given you some ideas for how you can use these devices in your own projects, and it's shown you how versatile the IR remote library actually is. Now if you need any of the code for the experiments we've done here, you will find it along with a detailed article about everything on the dronebotworkshop.com website. So please go and visit that. You'll find a link below the video to that. And if you haven't subscribed to the channel yet, please do. I would really appreciate that. Until next time, I hope you take care of yourselves, and I will see you soon here in the workshop. Bye for now.